Let's take a look at section 1.3. In this section, we are going to look at exponential notation. And when we multiply the same numbers, we use exponential notation to simplify our task. So for example, if we say 10 times 10 times 10, that can be reduced down to 10 to the third power. So it's just a simpler way of writing things. So 6 times 6 times 6 times 6 times 6 is 6 to the sixth power. And then 15, let's see how many times that is. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 15 to the ninth power. So this is exponential notation. We talked a little bit about this in our last section. Let's get kind of a formal definition next. For any non-zero number b, and any counting number n, we have b to the n. All right, so b to the n power. So b is our base, and that's what we call the base. You write b out n times, n factors. Okay, so that is our definition. Now, there are some identity rules that go with exponential notation. So the first, this is an example, b cubed or b to the third power is b times b times b. We also can say 5 to the third power is 5 times 5 times 5, which is 125. Now we have another identity rule is that anything to the zero power is 1. And I can prove this to you, or you can just take my word for it. It's one of these identity rules. So anytime you see 0 as an exponent, the answer is 1. So it doesn't matter what the base is. If 0 is the exponent, the answer is 1. So if you look at this next one, x to the 0 power, what is the answer? 1. 500 to the 0 power, what is the answer? 1. XYZ to the 0 power, what is the answer? Hopefully you can guess it. It is 1. Okay, so no matter what, if you see 0 as the exponent or the power, the answer is 1. So that's an identity rule. Okay, so we have one more identity rule, and it deals with a negative exponent. We don't like negative exponents too much. So we don't like them typically. Sometimes you will see them, and actually in this section you will see negative exponents, but sometimes you'll be asked to make negative exponents go away. So how do we make them go away? Well, negative exponents, we can make them go away by doing what I call the fix. And to fix it, we flip it and change the sign. So that's just kind of my Southern Alabama way of changing it. And so we flip it and change the sign. So let me give you some examples of how this works. Let's take a look at x to the negative 2 power. So in order to make this be a positive exponent, what we're going to do is we're going to take and we're going to put the x to the 2 in the denominator. So here, this is understood to be over 1. This is, it's in the numerator right now. So I'm going to take the whole thing, move it to the denominator, and when it moves it to the denominator, it becomes a positive 2. All right, so I know that's kind of weird, but it is a mathematical way of fixing it. Now, k to the negative 5. K to the negative 5. We can fix that one the same way. we can take and flip it and put 1 over k to the 5th. So we will just take and move k to the 5th down to the denominator, and it becomes a positive 5. Now this works the same way if you have a negative exponent in the denominator. So notice here we have a to the negative 9th in a denominator. So if we want to make this positive, we can just move it to the numerator and it becomes a positive exponent. So a to the 9th. All right, so these things, 1 over a to the negative 9th is exactly the same as a to the 9th. All right, and then what do you think this one? How could we fix this one? Flip it and then change the sign. So flip this, move it around. So this would become t to the what? Positive 12th. Okay, now one last example on this page. This is a weird one. We've got negatives everywhere. Now, if we have a negative in the numerator, we can move it down to the denominator. And if we have a negative in the denominator, we can actually move it to the numerator. So we're actually just going to swap these around. We're going to swap them around, and then everybody will be happy. So it's just going to be, we're just going to flip this whole thing upside down. So it becomes y to the 5th over x to the 3rd. And then everything is positive. Okay, so that is an identity rule. All right, so that's just a quick identity rule that you will need to know. Okay, now we're going to move on. The next thing in exponential notation, we are going to talk about 3 different types of notation: fixed point notation, scientific notation, and floating point notation. So the typical way that you write numbers every day is known as fixed point notation. So what you see right here, 12.98, that is called fixed point notation. That is what you commonly already know. That, you just didn't know that it was called fixed point notation. Now, the second way is scientific notation. You probably remember learning this. You may just, it's probably been a long time. So the way that scientific notation works is that your base number has to be greater than 1 and less than 10. That's where we have to do. The base number has to be greater than 1 and less than 10. So our base number in this case is 12.98. So our base number is 12.98. And it says it has to be greater than 1 and less than 10. So here, 12.98 is greater than 1, but it is not less than 10. So we have to move the decimal place to make it less than 10. So that's where scientific notation works. So I'm going to take my 12.98 and I'm going to move this decimal place. Now I'm going to move the decimal place, and I have to move this and make it smaller because I have to move it to the left so that it becomes a number less than 10. So when I move it one time, that becomes 1.298. Now, 1.298 is a number that is greater than 1 and it is less than 10. So that will solve my problem. Now, how you write it in scientific notation is 1.298 times 10 to the first. Now, the reason we got 10 to the first is that we moved our decimal place one time. So 10 to the first, I moved my decimal place one time. So this is scientific notation. This number right here and 12.98 are exactly the same. They're just two different ways of writing the same number. Okay. So we have fixed point notation, scientific notation. Now, whenever you are working on your homework, you have one other problem that you have to deal with, and that is in WebAssign. In WebAssign on the computer, you will have something that looks like this on your computer screen. And this is how, and a lot of my students are just like, what are we supposed to do with this? So this is how it looks on your computer screen. So this is your answer, and this is how you're supposed to put it into the computer. So actually, if this is your answer, what you're supposed to do is you're supposed to put 1.298 in the first box. You actually type it in there, and then you put a 1 in that second box. So you can kind of see that's 1.298 times 10 to the first power. All right, so that's how you would put this answer in WebAssign on the computer. Okay, so I told you there were 3 different ways: fixed point notation, scientific notation. Now, the third way is called floating point. Floating point notation is a calculator notation. So it's very similar to scientific notation. So except that you don't have the times 10. So this is called floating point notation. So this is our same number, 1.298. And instead of saying times 10 to the first, you just have either like 0, 1. Sometimes you'll have just a 1 out here to the side. Sometimes you'll have like a positive 1. It's written many different ways, but this is a typical way that you'll see it. So now how you'll see this on your homework is you'll see it in multiple choice format, and you'll see all of these different options, and that they will try to confuse you in many, many different ways. And so you will have to really pay attention to this and pick the right answer. So in this case, like that is the right answer there, that one in the middle, 1.29801. So I have a lot of students that will actually, whenever they see floating point notation, they will think that they're supposed to say 1.298 plus 01, and they'll like add those numbers together and get like 2.298. I always get something weird. So just be real careful and come back to this video if you get confused about floating point notation. All right, let's take another example of this. So let's now look at fixed point notation of a very small number. So this is a very small number, 0.0006578. Okay, so let's see how this is going to be different. So in scientific notation, remember we have to be greater than 1 and less than 10. So right now our problem is that we're less than 10, but we are not greater than 1. So we have to move the decimal place until we are greater than 1. So we are going to move this 1, 2, 3, 4 times would give me to a point where I am greater than 1. So I am at 6.578. Now, here's where things are a little different. This is now going to be 10 to the negative 4th. Now, why is this a negative 4? Well, it turns out this is a negative 4 because I started out with a really small number, and I moved my decimal place to the right. If you are dealing with small numbers, this is always going to be a negative number. Okay, so if you're moving your decimal place to the right, then this is going to be a negative number. If you move your decimal place to the left and you're getting bigger and bigger and bigger, then you're going to have a positive exponent. So that kind of is something you really just once you practice and do this more and more. But The smaller the numbers, this becomes a negative exponent. Bigger numbers have positive exponents. Okay, so 6.578 times 10 to the negative fourth. Let's see how you put it in WebAssign. So you'll put 6.578. You're actually going to have to type in -4, which is just the minus sign and 4. Okay, so minus sign and then 4. Okay, now let's look at floating point notation. So floating point notation does look a little different. And so this does look like a subtraction problem because of this minus sign, but this is how floating point notation looks. In WebAssign, you're going to have all of these problems and multiple choice format. So it's going to look something like this. So you're going to want to pick the correct answer, which is going to be the last one here, 6.578. -0.4. Okay. Now, hopefully you're good with these. We're going to look at several examples where we're going to kind of go backwards now. We're going to go back from various formats back to fixed point notation. So let's take a look at, we are 4 to the -2. And I want to go to fixed point notation. So 4 to the -2, fixed point notation. So you have some different options on how to do this. One of the things that I want you to get in a habit of doing is using a calculator. Now, your choice of calculator, if you have a calculator that you feel very comfortable using, you just have to be careful whenever you're using negatives and exponents and fractions and all of that. I suggest using a good scientific calculator. For the purposes of this video, just so that everybody can kind of get a calculator that everybody can access, Google actually has a free scientific calculator. So I'm going to pull that one up. So if you just Google and you just Google free scientific calculator, this is what you get. And it's actually pretty decent. So, so I kind of like it. So I'm going to show you how to do these examples on this calculator because everybody can access this calculator on any device. You are going to do 4 to the -2. So on this particular calculator, you will do 4, and then you're going to do your exponent. And then to do a negative, you just do the minus sign 2. So it's just like you see it. Now, in some calculators, and then you hit equals. On some calculators, you will actually hit, there's like a plus minus key. And so you'll actually hit that positive negative key. But in this particular calculator, you just hit the minus sign. So this gives you the answer 0.0625. All right, so on here, we will go 0.0625, and that would be your answer. Okay. Now, the next example, we have 4.78 times 10 to the -3rd. Now, we can use our laws of exponents on this, and let me see if I can make this screen go away. There we go. Okay, 4.78 times 10 to the -3. So what we'll do on this is that we will move our decimal place. And remember, this is a negative exponent, okay? So if this is a negative exponent, that means that this is going to be a very small number. So you want to move this. If you're trying to ask yourself, am I going to move this to the right or to the left? Well, if this is a negative exponent, then I need to move this decimal whichever way makes this a very small number, which would mean I need to move it to the left. So I'm going to move it to the left, 1, 2, 3. So there I go. So I'm going to move this 3 times. So whenever I do that, I would have my answer as 0.00478. And you can always check that. If you did that, you would move this decimal. You would say 1, 2, 3. We would have to move that 3 times. And that would be where this came from, 10 to the negative 3. Okay? All right. So 4.78. So that would be the answer that you would type into WebAssign. All right, now we have a number. This is actually in floating point notation. And again, this is where I have a lot of my students that will want to, they will want to take and just grab a calculator and they'll say 7.98 minus 6. And they'll give me an answer and it'll be like 1.98. Because that's what they did in the calculator, but that's not what this is. This is floating point notation, which means this is really like 7.98 times 10 to the negative 6th. Okay, so that means then that this would be 10 to the negative 6th, which means, is this going to be a big number or a small number if this is a negative exponent? Means that it's going to be a very small number. Okay, so am I going to move this decimal place to the left or to the right? It means I'm going to make this a small number, so I'm going to move it to the left 6 places. Okay, so when I move that decimal point to the left 6 places, you get this really small number. So when you move it to the left, I have to add 5 zeros. 1, 2, 3, 4, 5, and then 7, 9, 8. All right. Okay. Now, here is another floating point notation, and I told you that floating point notation has different ways that you'll see the answer written, and this is another way. It's another way that you'll see a positive exponent written, where it says E and with a positive 4. And so this would be telling you that this is going to be a pot like 10 to the 4th. So what this means is that you would move your decimal place to the right 4 times. Okay, and so then you would have 56,100. Okay, so all of these answers are in fixed point notation. You have several of these on your homework. All right. Okay, now we have a couple of these on your homework assignment. I've taught this multiple different ways over the years, and I have found that this is the absolute easiest way to teach this, is basically to, this looks like a really ugly problem, but it turns out to be not nearly that bad. So what we're going to do is we're going to take this problem and we're going to simplify it. We're going to take this and we're going to get it out of scientific notation. Then we're going to use our calculator and we're going to work it out. And then we're going to put the answer back in scientific notation because that's the way they want it in WebAssign. Okay, so let's work through these steps. We're going to take each individual part. So we're going to take 4 times 10 to the 4th. So let's take this out of scientific notation and put it in fixed point. 4 times 10 to the 4th. It's actually pretty easy. 4 times 10 to the 4th is just 4 with 4 more zeros. Okay, so 4 with 4 zeros is 40,000. And then 6 times 10 to the 6th is 6 with 6 zeros. So that would be 6 million. Okay. And then 3 times 10 to the 5th is 3 with 5 zeros. So you have 300,000. All right. Now, this is where you grab your calculator. So let's grab the calculator again. All right. So we're going to grab our calculator and we're going to say, all right, so I'm going to clear that out and we're going to say 4 with 4 zeros, 1, 2, 3, 4, times 6 with 6 zeros, 1, 2, 3, 4, 5, 6. And then I'm going to go ahead and hit enter because that's my numerator. And that's a really big number. And I really probably should write that down, but since it's in my calculator, I'm not going to worry about that. Okay, so that's your numerator. That's the 40,000 times 6 million. Now I am going to hit divided by. So divided by the denominator, which is 3 with 5 zeros. 1, 2, 3, 4, 5. And then I'm going to hit enter. And you get this 8 with 5 zeros. Okay, you get 800,000. All right, that is your answer, is 800,000. All right, so in WebAssign, you're going to have this answer block, and it's going to look like this, because that's how they're going to want the answer. So now you just have to take 800,000 and put it into scientific format. So in scientific notation. So that's not hard at all. We just take, and our decimal place is here at the end. We're going to move it until we get all the way to the 8. So that's 1, 2, 3, 4, 5. So I moved it 5 times. So it's 8 times 10 to the 5th. So really, it looked like an ugly problem, but it really turned out to not be bad at all. It's a calculator problem. And I like those. They're not bad. Okay. So let's look at one more of these that's just slightly a little bit more difficult. All right. Threw in a negative exponent here. So just a little different. So let's take a look at this. All right, on this one, remember we're first going to take each individual one, put them into fixed point notation, and then use our calculator. All right, so 6 times 10 to the negative 6th. This is negative 6, that means it's a small number. So really, I'm going to make this a small number. So it's like 5 zeros and then a 6. Okay, so that's what we get here. So 1, 2, 3, 4, 5 zeros and then a 6. All right, and then you're going to have 8 with 8 zeros, big number. 8 with 8 zeros. Okay, and then in your denominator, you're going to have 6 with 5 zeros. All right, then we're going to grab our calculator. All right, so let's clear this out. And we're going to do point, and we're going to do 5 zeros, 1, 2, 3, 4, 5, and a 6. And then times 8 with 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to hit enter. And then I'm going to hit divided by. And I'm going to do 6 with 5 zeros. 1, 2, 3, 4, 5. Enter. 0.008. Okay, 0.008. All right, so then remember we have WebAssign. In WebAssign, they're going to want your answer like this. So we have 0.008. So I'm going to have to move this decimal place 1, 2, 3. So I have 8 times, now what's going to go here? I moved the decimal place 1, 2, 3 times, right? But do I put a 3 here? What goes here? What do you think? This is a very small number. So hopefully you see that a -3 goes there. Okay, so 8 times 10 to the -3rd. Okay. Alrighty. Now, the last one is how many classrooms would be necessary to hold 1 million inflated balloons? Assume that one balloon is about 1 cubic foot and a typical classroom is 35 feet by 27 feet by 9 feet. Round your answer to the nearest number of classrooms. Okay, so we have to remember first the volume for a classroom is length times width times height. So we're looking at like a rectangular classroom. So if we're looking at the classroom that they gave us the dimensions of, we have 35 by 37 by 9. I think I changed in your notes. Okay, I did. So I apologize. Here in my slide, it says 27, but I ended up changing this to 37 in your notes. So just pretend that that says 37. All right, so then when you multiply that out, that's 11,655. 11,655. Let's double check and make sure I did that right. So 35 times 37 times 9. Yes, 11,655. Okay, then what you're going to do is you're going to take 1 million because you have a million inflated balloons and you're going to divide it by that total amount of volume. And when you do that, you get 85.8, something around that. Let's see what you get exactly. 1 million divided by 11,655. All right, so you get this long number here, but it's somewhere close to 85.8. All right, so this, though, says to round your answer to the nearest number of classrooms. So in other words, you can't have 85.8 classrooms, but 85 classrooms would not hold it because you still have to have at least 0.8 more. So you would need at least 86 classrooms. So that would be your answer, is 86 classrooms in this case. All right, you have a few word problems that are similar to this, where you're going to have to use some estimation and things like that. All right, that is section 1.3. If you have any questions, please feel free to reach out to me.